Hey everyone, this is Kane here. So I'm just going to go through some examples of how to figure out the names of certain compounds. Okay, so our first compound is going to be BAF2. Okay, so we've got some questions that help guide us through naming. So our first question is, does it start with hydrogen? If we're looking, hydrogen's not even in this compound, so the answer is no. So it doesn't start with hydrogen, so it's not an acid. So we don't need acid rules. Our second question is, are there more than 3 elements? So if we're looking, look at your capital letters, okay? That tells you how many elements you have. We have barium, we have fluorine, so those are our 2. So, since we do not have more than 3, it's not polyatomic. We don't need any special names. Our next question is, are our elements all nonmetals? So, can they both be found on the right side of our periodic table in groups 13 through 18? Okay, fluorine can be, but barium is not. So the answer is no, not all are nonmetals. So we do not need prefixes. Okay, question 4 that we're going to ask ourselves is the metal, okay, so metals are always the first ones, is the metal a transition metal? So is it in groups 3 through 12? The answer is no, barium is not. So we do not need Roman numerals. Okay, no Roman numerals for this one. So first thing we're going to do, we're going to write barium's name. So there you go. Just writing barium. Then we're going to come up to fluorine. Okay, we're going to write down fluorine, but we're going to change the N to IDE. So take the INE off of fluorine and make it IDE, so it becomes fluoride. So the name of our whole compound, okay, is barium fluoride. All right, so now we're going to look at another example. Okay, so we've got carbon and we've got bromine. Okay, so first question is always the same. Does it start with hydrogen? No, it does not. So that means not an acid. Okay, we're coming back to question 2. Are there more than 3 elements? Look at your capitals. 1 for carbon, 1 for bromine. So no, we do not have more than 3 elements, so it is not polyatomic. Okay, we're coming back. Both carbon and bromine can be found on the right side of the periodic table. So that means they're both nonmetals. We're looking at groups 13 through 18. Okay, since they are nonmetals, we need prefixes. And we know we have no metals, so we don't have to worry about those Roman numerals with their transition metal. Okay, so we're coming up to writing down the names. So we know that carbon, there is only 1. Okay, we have no subscript right here. So we are going to write the name with no prefix because there's only 1 of them and it is the first element in our compound. Okay, so we're just going to write down carbon. Bromine, okay, there are 4 of them, and it's the second element, so we need a prefix, and we are going to change the N to IDE. So, for our prefix is tetra. Okay, so that tells us we have 4 of them. And then we take bromine and change the INE to IDE. So bromide. So our whole compound's name is carbon tetrabromide. Okay. We're going to do one that is a little bit more difficult now. Okay, so if you look at this one, first thing off the bat we should notice is we have 3 capital letters. So that should be cluing you in, hey, this guy right here, this group, is a polyatomic ion. Okay, So, first question always, does it start with hydrogen? No, it does not. So it's not an acid. This time, though, we have more than 3 elements. So we have a polyatomic, which we said was this PO4 right here. That's a group. It acts like one thing. Okay, so we're going to look at our chart and we're going to find out that the name is phosphate. Okay. So when we're looking, we already know we have a polyatomic ion. So we know not all of our elements are going to be nonmetals. So we do not use prefixes on this one. This one's a little tricky because copper, okay, the Cu, that is in our transition metals. So we know that the metal is a transition metal, so we need to find our charge and add the Roman numeral. Okay, so if we're looking at this, we're going to bring both these down. We know off our chart that phosphate has -3 charge. Okay, so when we are making a compound, we have to have an equal amount of charge. Okay, we want it to be neutral because, again, we do not have that nice little charge symbol up here. So we know that all of our electrons are bonded. Okay. So, how many of the copper do we need to balance the charge? So, we know, looking at our chart, that copper can be +1 or +2. Okay, but we have a -3 over here on the phosphate. And if I'm looking up here, I can see a 3 here as well. So that's telling me that I need 3 of these coppers to balance out 1 phosphate. So the way I'm thinking about this is, in order for phosphate and copper to even themselves out, copper needs a +1 charge. Okay, so we're saying that if copper has a +1 charge, 3 of them would cancel out the -3 charge on this phosphate. Okay, so we know copper has a +1 charge. That's why it gets this Roman numeral right here. So we're going to write copper. We're going to put the Roman numeral after it. So whenever you see this, this is telling you what the metal's charge is. Okay? Because it can have multiple charges, we need to put that in there so we know. And then we're going to write the name of the polyatomic. So, copper phosphate. Copper 1 phosphate if we're being very specific. All right. Lastly, sorry guys, the board's falling over there. We're gonna do an acid. Okay, so this one's a little tricky because if you notice, 1, 2, 3 capital letters. Plus, we know we have a hydrogen in the front, so we are following acid rules. Okay. Question number 2 still applies. Are there more than 3 elements? The answer is yes. So there's a polyatomic ion in there. And here's how we remember our acid rules. Okay, so my ride has hydraulics. So if your second element is not a polyatomic, it's going to end in IDE. We know that we will need to change, okay, the way we're writing it. So it would be hydro, enter name, so like hydrobromic acid, okay, if it's HBr. If you have a polyatomic ion, you need to watch the endings. So you're either going to have an ATE ending or an ITE ending, and they both switch and become something different. So the way we remember, if your polyatomic ends in ATE, you change the ending to IC. So I ate something icky. That's how we remember that. If it's a polyatomic that ends in ATE, its ending changes to IC. If our polyatomic ends in ITE, we're gonna change the ending to OUS. So we remember this by Sprite is delicious. Okay, so when we're looking at this, we have hydrogen, okay? And we know that it's bonded right here to a polyatomic ion, okay? So, since it's bonded to a polyatomic ion, we don't use this hydro prefix. Remember, hydro goes with IDE. So when we do not have a when we do not have a polyatomic ion, then we use hydro and the ending of IC. Okay, so if we're looking at this group, this is perchlorate. Okay, you have chlorine and 4 oxygens. That whole group is a polyatomic, and it's called perchlorate. So since it has the ending ATE, we know we're going to change this ATE to an IC. Okay, so perchlorate becomes perchloric, and it's perchloric acid. All right, so that's a brief tutorial on how to name.